Hey everyone, how's it going? In this video we'll be solving this Leetcode problem of TwoSum. The problem statement goes like, given an array of integers nums and an integer target, return indices of the two numbers such that they add up to a target. Okay, so here are our nums given and here is our target. We need to find the indices that add up to the target element. So here it's returning 0 and 1. Since 2 and 7, the elements at the indices 0 and 1 add up to 9. Since 2 and 7 add up to 9. Okay, and in this case here it's returning 1 and 2, since 2 and 4 add up to return 6. Okay, and what is it saying? You may assume that each input would have exactly one solution and you may not use the same element twice. So if the target in this case was given like 14 or something, we cannot use 7, we cannot return 1 and 1, since we cannot use the same element twice. We cannot use 7 and 7 to add up to 14. Okay, this is a good problem, and this is also the first question on Leetcode. So let's see how we can do the brute force solution. The brute force solution would go something like, we would have two pointers. One pointer would be at the starting of the array, and the second pointer would check all the elements starting from the next element of the start pointer. Like if we have an I pointer at 2, then the j pointer will start from 7 and it will check for all the elements. Does adding 7 to 2 add up to 9? Yes. If that was not the case, if 11 was at first, adding 2 plus 11 does result in 9? No. Adding 2 and 15 result in 9? No. Then the loop will break and we would and the I pointer will move forward. So I pointer will check from here now 7. Thus adding 7 and 11 add up to 9? No. Like this will go. Okay, so let's check out the solution. The solution would go something like, this is 2 pointers, so we would have 2 for loops. So the first for loop would start, the ith pointer will start from 0, sorry, I plus plus, and the j pointer would start from the next element of I, like that is int j equals to I plus 1. I plus 1. J would run till nums dot length j plus plus. Then we would check for the complement, if the complement is there or not. So target minus nums of I. We are taking the we are storing the complement of, we are negating from the target the current number at index I. Okay, so and we are storing it in the complement, and in the next step we will check if the complement exists. Complement if if nums of j is equals to complement, then we would return answer, return new int I comma j. So this is how it will go, and if we are not getting an answer, then we would return throw new illegal argument exception, no match found. Okay, let's check if this code runs. Okay, this code runs. Let's submit it once. Okay, this submits, but as you can see, the runtime is the algorithm is actually lot slower. So which is like 32.5% of the solution. A lot slower. 49 ms is lot slower. So for large amount of data, this algorithm would be like very slow, very slow. We cannot use this algorithm. So what we need to do is optimize this solution. How can we optimize the solution? We could use something like a map. What is a map? You can check up on Google. Map is like a data structure which stores the keys along with their values. If we're storing any value, it will store their keys too. Okay, so you can check up on that on Google. So what we need to do is we would need to use a map. So map, the key, integer key, the value would be integer 2, integer answer underscore map equals to new hash map. We are using hash map in this case. Hash map, and now this is a 1 plus solution. So for int I equals to 0, I less than nums dot length, I plus plus, I plus plus, int complement equals to target minus nums of I. Now we would need to check on the map if the element exists in the map or not. Okay, if the element exists in the map, then we would return the answer. So we would do something like int answer map dot contains key. Check up on the contains key method on Google. You will get it. It's not something very complicated. Complement, if this exists, then we would return new int answer underscore map dot get complement comma I. So we are returning the index in this case and also the complement of the number. Okay, and if nothing is in the map, if we are not finding in the map, if we are not finding the element in the map, then we would need to put in the map. So we would need to put all the elements one by one in the map. Okay, so answer map dot put answer map dot put nums of I comma I. We are putting the index and the number into the map. Okay, and if it not runs, then we need to throw error. So I guess this will run. Let's see. Yes, this has run, and let's submit. Okay, this has submitted, and as you can see, this is a lot faster algorithm, like 1 ms and 49 ms, bro. 1 ms and 49 ms is hell and heaven difference. So this is the solution for the TwoSum method, TwoSum question. TwoSum question. I hope you enjoyed the video. If you like the video, press subscribe and like, and I would be returning with a new video tomorrow. Bye.